All right, this section is just the backwards of the last video, okay? So we're going to be finding equations of rational functions from graphs and from descriptions. And in order to do that, we're going to use the three things to include in a graph from the last video and just work in the opposite direction. And specifically, we know that all rational functions are going to have this form, okay? X minus x1 to some power and a whole bunch of factors. We don't know how many factors there's going to be. There's just a bunch of factors on the top with different multiplicities. Well, I guess not every rational function because it might not. That's an interesting question. I think definitely everything in this class, but it's a more interesting theoretical question than I had first thought. And on the bottom, we have a bunch of asymptotes or removable discontinuities. We're going to write them with slightly different. But the point is, it's just a bunch of factors on the top that are zeros and multiplicities, a bunch of factors on the bottom that are asymptotes or removable discontinuities, and then some sort of scaling factor. Okay, let's do an example. We'll do it on the, no, we'll do it here. Why not? Example 7, find an equation for this graph on Desmos. So find an equation for this rational function. We're just going to go kind of backwards and identify all those things from before. So looking at 5.6.5, hopefully you got good notes in 5.6.5. We're going to start by looking at intercepts and multiplicities. Intercepts and multiplicities are going to have to do with this. Y-intercept we actually can't do until the end, but we can do X-intercepts right now. What are the X-intercepts here? The X-intercepts look like they're at about -2 and +3. -2 and +3. What are their multiplicities? Is it bouncing off, crossing like a cubic, crossing kind of like a line? These all have multiplicity of 1, these zeros right here. Right? We're not bouncing off or doing anything weird with curvy. They're regular old X-intercepts. I think these are the only times we cross the x-axis. We have an asymptote here, but again, multiplicity 1. So we know, we don't know A yet, but we know that our zeros, we're going to have factor of x plus 2 up here and a factor of x minus 3 up here. All right. And there are no removable discontinuities. That would be given. It would be obvious. But if there were a removable discontinuity, then we'd add that factor to the top and the bottom. Okay. We got the zeros and the multiplicities, the y-intercept. We're going to have to incorporate a little bit later. The y-intercept here is at y equals -2. Right here. Let's save this for later. That's how we're going to find our scaling factor. Okay. What else do we want to do? We want to look at vertical asymptotes and their local behavior. And again, we already said there's no removable discontinuities. So let's look at vertical asymptotes and their local behavior. The vertical asymptotes, there's one at x equals -1, right? There's one right here, x equals -1. And there's one at x equals +2. What about their local behavior? On each side of these asymptotes, is the function going the same direction or the opposite direction on each side of the asymptote? Well, look at this asymptote, x equals 1. It's going to positive infinity on one side, negative infinity on the other. This opposite direction right here, it's going to have odd multiplicity because opposite direction. Whereas x equals 2, they're both going down to negative infinity. So at x equals 2, we know that's going to have even multiplicity. Good. So on the bottom, that has to be an x plus 1 for that asymptote. And an odd multiplicity, let's just say 1 for now, for the exponent. And even is x equals 2, this should going to be x minus 2. But we know that there has to be an even exponent on that denominator. We also need horizontal asymptotes or slant asymptotes. We should check that. There's a horizontal asymptote at 0. So the end behavior should be like 1 over x or something. We look it over here. The end behavior. Well, if we looked at the end behavior, it'd be the same as the end behavior of the leading terms. End behavior with the leading term on the top is x squared. Leading term on the bottom is x cubed when we multiplied it all out. So yeah, the end behavior is like 1 over x in our little guess. So all that's left is to find out that a value. Everything else is looking pretty solid. The y-intercept is -2. The y is -2 when x is 0. Solve for a. All right, so when we do that, what we're going to get, that's not what I wanted to grab. What we're going to get is that -2 is equal to, this becomes, oh, let's just do it out the long way. This becomes -6 on the top and +4 on the bottom. -2 is a times -3/2. And multiply both sides by the reciprocal, -2/3. We should get that a becomes +4/3. So our guess becomes +4/3 is our coefficient. X plus 2x minus 3 has to do with our zeros on the top. X plus 1 and x minus 2 squared have to do with our asymptotes. Oops, I just got rid of that. So this is our guess. The last thing that we do, and this is going to look a little weird when I do it, because I have the answer on Desmos already. The last thing you're going to want to do is you're going to want to graph this on Desmos and make sure it's the same thing. But in our case, I've already written it down. Let's just make sure it's the same thing. Coefficient is 4/3. We've got that. X plus 2x minus 3. We've got that. X plus 1 over x minus 2 squared. We've got that. Yeah. You'll want to graph this and compare it to the graph that's been given to you and make sure it has everything you need. We'll do another one of these in the selected homework problems video, but this should be enough to get you started. Good luck and let me know if you have questions.